Okay, so this is phase 14. So you're given the graph of f up here, and I'm giving you like the areas underneath the graph of f. And I'm also giving you the following accumulation functions. So these are these functions here. They're called accumulation functions. So you know something's an accumulation function if it's defined using an integral, and the top these are called the limits of integration, and the top limit of integration, which is like an endpoint of the interval, is usually the right endpoint, sometimes it's the left endpoint of the interval, is the variable. So the input, so I'll show you how this works, but whatever the input of this function is, like m of 2 would be the integral from 10 to 2 of f. Now this variable w is called a dummy variable. It could be any variable as long as it's not the same as the input variable. Because if this was also an x, if the w was also an x, that would mean that if I plugged 2 in, if I did m of 2, it would be the integral from 10 to 2 of f of 2 d2. That doesn't make any sense. We don't want that. We want the integral, you know, we want this variable to be different. Okay, so we're going to find the indicated values for numbers 1 through 8. So number 1 is m of 13. So this is number 1. So I'm going to take, so I want m of 13. So this is m. So m of 13 is going to be the integral from 10 to 13 f of w dw. Okay? Now the integral from 10 to 13, that's the area under the curve of f. So there's 10, there's 13. So you add up all these areas here. All right, so this first one, it's going to be, so it's going to be this area. 1, 2, oh shoot, it's only, no, it's these. Okay, the area from 10 to 13. So it's 11 plus 10 plus 9. What is that, 30? Yeah, it's 30. Okay, now number 2, same accumulation function, and it's called accumulation because the area accumulates. Number 2 is m of 7. That's the integral from 10 to 7 f of w dw. So from 10 to 7, so this is a backwards interval. All right, so from 10 to 7 going backwards. So it's going to be this area. But if you're integrating backwards, it's going to be negative area. So from 10 to 9, that area would be negative 9. Then from 9 to 8, the area would be negative 8. From 8 to 7, the area would be negative 7. So we're going to end up with, what is that? 16 plus 8 is 24. I think that's, let me just not make a mistake. So 7 plus 8 plus 9. So negative 24. Negative 24, because it's a backwards interval. Okay, now we'll do number 3. So we want h of 13. That is this function now. So it's the integral from 7 to 13 f of w dw. Okay, so from 7 to 13. So this is a forwards interval, and all of this area is above the x-axis, so everything is positive. So I got to add up all of these areas from 7 to 13. So 7 plus 8 plus 9 plus 11 plus 10 plus 9, 54. H of 4, that's the integral from 7 to 4 f of w dw. Okay, so from 7 to 4, guys, this is a backwards interval. So we're going to have to negate the areas. But these areas, guys, since they are below, since these areas here, so 7 to 4, so since these areas are already below the x-axis, they're already negative, and now I'm integrating backwards, so we're going to end up with positive areas. So from 7 to 6, that would be negative, -3, so positive 3. From 6 to 5, the area would be negative, -5. From 5 to 4 would be negative, -6. So those are all positive. So we end up with 14. Okay, that's number 4. Now number 5. Okay, so g of 1. G of 1. Right, g is this one. So g of 1 is from 0 to 1, f of w dw. So from 0 to 1, the area is 2. All right, now 6. Now I want g of 2. That's from 0 to 2. Okay, so from 0 to 2, the area is 2 plus 4. That's 6. Oh, 5, 6, 7. G of 3, I don't know why I put that equals there. G of 3 is the integral from 0 to 3. Okay, the area under the curve from 0 to 3. 2 plus 4 plus 3. So that's 6 plus 3 is 9. And then one more. G of 4. The integral from 0 to 4. Okay, so 0 to 4. So I've got positive 2 plus positive 4 plus positive 3 plus this area here is below the x-axis. Oh, you can't even see. I'm sorry. So positive 2, positive 4, positive 3, negative 3.5, because it's below the x-axis, that one. So it's 2 plus 4 plus 3 minus 3.5, 5.5. Okay, now, almost done. An accumulation function is increasing when positive area is being added. So when positive area is accumulating, then the accumulation function is increasing. And decreasing when negative area is being added. So when negative area is accumulating, then the accumulation function is decreasing. So find the intervals over which g is increasing and decreasing. Okay, so we're going to start at 0. So these intervals are on the interval. The intervals are going to be subintervals of 0 to 15. So guys, and g is what we're asked about. So g of 1 was 2. G of 2 is 6. So g of 2 is bigger than g of 1. So, you know, getting bigger, increasing. And then g of 3 is 9. So from 1 to 2 to 3, we're accumulating positive area under the curve. So g was increasing, but then look at g of 4. G of 4 is less than g of 3. So it starts at some point, we start accumulating negative area, and therefore g is decreasing. So let me say increasing, decreasing. I'll go like that. Okay, so g increasing, g decreasing. So guys, starting at 0 to 3, we keep adding on more positive area, okay? So g of 1, g of 2, g of 3, we just keep adding on more positive area. So all the way from 0 to 3, we're accumulating positive area. So from 0 to 3, g is increasing. But then after 3, starting right after 3, we start adding on negative area. So we're accumulating negative area, more and more negative area, all the way up to 7. And then after 7, we start adding positive area. All right? So what this means is that g is increasing from 0 to 3. And then after 3, it starts decreasing from 3 to 7. But then after 7, it starts increasing again from 7 to 15. Okay, so on these intervals, we're accumulating positive area, accumulating negative area.